Welcome to the CIDCI Online Salon Series. I'm Margie O'Driscoll, and on behalf of the CIDCI Board of Directors, I'd like to welcome you here today. CIDCI's mission is to accelerate innovation, disruption, and change to improve the built environment. We create networks that share knowledge, experience, and ideas through productive dialogue. CIDCI is a not-for-profit organization that relies on your financial support to provide these programs. Thank you to our sponsors who make all of this possible. Today, there is enormous suffering in many countries due to the pandemic, especially in India. But there's also an emerging feeling of hope in many places around the world. As COVID vaccination rates start to increase, a feeling of optimism is starting to emerge. Many of us are hugging elders that we haven't seen for a year, or maybe attending a college graduation or a wedding. Our lives are transforming into a new normal, an entry into a new time that is simultaneously similar, but also so very different than the world we left in March of 2020. As we re-enter workplaces, airports, and sports stadiums, we hope that some of the difficult lessons of the past year strengthen our resolve to build back better. At CIDCI, we're starting to plan our fall forum, which will be October 4 to 8. As much as we wish we could be with you in person for the day, we believe that it is more prudent to do an online series. So we'll do what we did last year, 5 days of 90-minute early morning salons. These salons will feature innovative ideas with groundbreaking presentations and are designed to be shared widely with your colleagues. If you see something you want to share with a client or friend, feel free to direct them to the CIDCI website to hear recordings of all of our events. Okay, here's a bit of information about how today's session will work. We're recording the presentation and we'll put it on the CIDCI website as soon as possible. If you have questions or comments during the presentation, please use the chat box. Today's session will run for 60 minutes. Today we will explore a big question. How might we design a project as a catalyst for transformation? We have two speakers, Meredith Banasiak and Romano Nickerson from Boulder Associates. Meredith is the Director of Research for Boulder Associates BA Science Group. Meredith leads efforts to support a person-centered design culture. She brings experience in optimizing person-to-environment interaction by developing research partnerships with healthcare organizations, innovating novel methods for collecting data, and translating evidence with design teams. Her co-presenter is architect Romano Nickerson. He's a healthcare architect, a lean coach, and a principal with Boulder Associates. He's a passionate advocate for lean design and construction and is the founder of BA Science, a consultancy within Boulder Associates. We're so delighted to have both of you. I think, Meredith, are you going to get us started?
Yes, thank you, Margie. We're thrilled for the opportunity to engage with this group of innovators. So as Margie mentioned, we're bringing a question to the group today that we've been exploring the past few years. How might our design projects provide a bigger opportunity for organizational transformation? And we're approaching this question, this topic, from the perspective of facility designers. Romano and I work with Boulder Associates Architects, and this is a design practice which is 100% healthcare and senior living projects. And we're also approaching this topic from the perspective of the domains that we direct at Boulder Associates. So as Margie mentioned, my background is researching and studying these human environment interactions. I got my start with the Academy of Neuroscience for Architecture when it was first first launched back in 2005, and was faculty in human factors in design and planning at University of Colorado for about 9 years. And Romano, share a little bit about your background.
Well, I also came to Boulder Associates to get involved in the healthcare practice, but then one of our clients became very interested in lean construction, and that led me into the world of lean, which has now included the operations of our clients as something that I'm very interested in. And so As we've gotten deeper into trying to understand the value that we can provide for our clients, and the understanding of how they bring capital projects into their to the table, and what they're seeking to achieve, we've come to realize that we need to do more than just simply, put up a building that's suitable for their needs. That we have to really delve deeper and understand how they need to operate, and really help provide recommendations and challenge them in ways to help them improve. So I was really excited today to have an opportunity to collaborate with Meredith and talk about what we've been learning.
Great. And what's special about Boulder Associates and relevant to our topic today is that Romano and I, along with our sustainability counterparts, joined forces under a common umbrella that we call BA Science. And so we were, in doing this, we were really able to integrate our efforts. We consider BA Science the innovation arm of Boulder Associates. We formally launched about 2 years ago and brought together these domains which were previously siloed in human factors research, process improvement, and sustainability. Romano, do you want to add anything about BA Science?
Yeah, and part of this was that we really wanted to make an effort to build expertise as something, as its own thing, separate from the notion of experience. I mean, because we and other designers have spent years learning, but to really try to develop the knowledge that we have within our particular domains, and to understand, to seek to understand and contribute to the knowledge of our particular channels, as we call them, not just within the firm and on for the benefit of projects, but within the industry itself. And so been just a very deliberate effort to build that type of expertise, and then to bring that to bear. Science also has allowed us to not just work on projects that the firm is doing from a design perspective, but also to consult externally. So we've had an opportunity to work for a number of Fortune 500 companies and automobile manufacturers, et cetera, to provide consulting for them, and then to be able to take that learning from outside of design and construction and bring back some of that thinking into the industry that we all share.
So the more that our BA Science team worked together, the more we began to understand our built environment projects holistically as a system of spaces, relationships, and operations. And while this might seem like I'm stating common sense, it's not how we as a design industry traditionally design and deliver projects. Oftentimes, our designers have little knowledge about how a health system works, its operations and processes. And even when we do have that knowledge, we're often asked to create spaces that would replicate their existing state of operations and processes and relationships. So this is really a missed opportunity here. New facility projects, construction and renovation, can support new behaviors for operating and interacting differently. So when we make the effort to vision future state of that whole system, the operations, the processes, and the relationships, we can, then in parallel be designing to support those new interactions. So again, I said this is not really a novel idea. So where's the innovation? The innovation is, how do we do this? Because as an industry, we're not doing it. So we need to change. So how do we use the design of a new facility as a catalyst to optimize and transform the system and create the watershed moment? So we're going to talk about a few ways that we're doing different things at BA Science, and we'll just use the traditional design process as our outline today to show some examples of how we're interjecting ourselves into these more conventional design phases. So starting with pre-design, or just more broadly, project's earliest conceptual stage, we collect data. We collect current state data to develop target goals for a project by understanding what's not working well, what is working well, and also to have a measurable baseline. We want quantifiable data to be able to test any new models against. And data is really important to our future. I was listening to NPR Science Friday last week, and they had a UC Berkeley doctor on, and he said that everyone agrees the future of medicine or healthcare is all about data. And what he was describing was really moving from evidence-based medicine to actually machine learning, where algorithms are reading X-rays or reading biopsy samples and making medical determinations and diagnoses. So for us as a group who serves healthcare clients, we have to get on board with this data-driven trajectory. And when we recognize the future is about data, we can align our design process accordingly and use data to guide decision making. So the types of data that we collect during pre-design include a lot of operational data um, to guide kind of process improvement. So we look at throughput and waiting times, clinical outcomes, falls, patient satisfaction, and we'll compare that data with system-wide as well as industry-wide to help set targets for process and operational improvement. So that data is great for helping us get to kind of process improvement targets, but it's often a pretty indirect correlate with how we're evaluating our physical spaces. So we also need to benchmark the effectiveness of the spaces themselves, the physical environments, and especially person-space interactions. So a first step is just kind of recognizing that environments are a physical and social construct. If we're only measuring the space itself, whether it's kind of energy efficiency or taking lighting levels of just kind of the empty space and not including the occupants, it doesn't represent that system. And it's probably measuring the wrong thing, or it's certainly at least incomplete data. So one way we can measure these interactions is to collect biometric data under different operational and environmental conditions, so we can better understand occupant response to those variables. So this is an example of a pilot study that we're doing to develop a data-driven journey map for building occupants. And we're calling it a mood map because our goal is to correlate stress with location and activity. So we use this ring, which I have on today, which is just a consumer grade wearable, and it measures skin conductivity. Essentially, it's measuring sweat, which is a good correlate for stress. And it gives us quantified stress measures. And then we also use Bluetooth low energy beacons and sensors, and that helps, that locates occupants within a building, which is hard to do with GPS and that sort of thing inside buildings. And then we also use mobile surveys to have occupants tell us what they're doing. And all of these are time stamped, so we're able to layer them into a single dashboard and look at the interactions between those three things: stress and space and activity. So this particular mood map here you're seeing was developed to compare office workers' stress. We just used our own Boulder Associates staff, and we looked at their stress when they were in an office workplace setting, and again when they were working from home, to see if there were any differences. And we just did this as a proof of concept to see if we could find meaningful stress data between the two conditions, and also to technically figure out how to build the dashboard and how to have it tell a bit more of a story rather than just be kind of a raw display of data. And we were successful. We did find some meaningful differences in stress. And so we're going to continue to use these mood maps in the future and develop them for patient journeys to understand where the stress points are in a patient journeys, so we can either eliminate those through process improvement, or recognizing that that a lot of healthcare journeys are just very stressful and we can't eliminate all those stress points. We can better design spaces to support and help patients manage stress. So we'll quantify stress before and after we make those changes to operations and space. And that's kind of an example of how we're starting to measure human environment interactions. So the other thing, besides, in addition to understanding that environments are physical and social constructs, is understanding that this system is dynamic, that we're trying to measure and develop tools um, for this kind of measurement. So how do we do that? How do we kind of evaluate the dynamism of this system? And here, I think we all kind of understand that we people are dynamic and change and fluctuate. But environments do too. Environments are dynamic too. And I'm not just talking here about longitudinal change over time, um, um, over a building's life cycle. We certainly want to account and design for that. But I think less talked about is those short-term changes that might happen either within a day or from day to day. One that we're familiar with is noise levels. So when there's activity, noisy activity that goes up, that can impact occupant performance. Maybe more mistakes are made. Less well known are some of these findings that came out of a recent study from the Government Services Administration, the GSA, and University of Arizona's Institute on Place and Wellbeing. And they collected a lot of data on office workers and office environments, and they found these types of environmental attributes which change occupant outcomes such as productivity and stress and alertness. So for example, carbon dioxide. When you're in a conference room and that's enclosed with a lot of people, and they're all breathing out, those CO2 concentrations are going to be higher. And if you're there long enough, it can actually lead to a decline in cognitive ability, cognitive performance. And this is also true when office workers are just sitting at their desk. So you can see in the picture that person has sort of a cloud, and what's happening is if they're not moving, they're breathing out CO2, and that's the air that they're inhaling back. So that kind of stationary position is just having them breathe in higher concentrations of CO2, and is associated with decreased cognitive performance, discomfort, and fatigue. Light intensity is another big one. So there's a lot of research. I'm sure you're all familiar with, like, don't use your devices at night because of the blue light coming from your computer screens or your phones is suppressing your melatonin, which is what is driving sleep. And so your sleep wake cycles get disrupted. So these are types of examples of environmental attributes which change and can impact occupant performance within a day, within very short time periods. The lighting exposure research specifically is something that we used to design a recent inpatient behavioral health unit. And for this unit, we wanted to support occupant well-being by providing lighting that changes over 24 hours, and that was aligned more with circadian rhythms or patient and staff sleep-wake cycles. So we used a tunable lighting system here. It was an LED tunable lighting system, which is able to be programmed to mimic changes in daylight throughout the day. So you can see the lighting program is the diagram at the top, and kind of beginning at that 7 a.m. Increment there. It follows what daylight is doing, the sun, in both color, temperature, and intensity. So in the morning, we want that blue light spectrum. We want our melatonin suppressed so that we are alert and awake and not falling asleep. And then beginning around 6:30 in the evening, as the sun goes down, we want to remove that short blue light kind of spectrum, so that melatonin's not being suppressed, and occupants can kind of go into their sleep cycle there. So there's a lot of lab-based research on these impacts of blue light on health, but there's very little data that's being collected in real-world settings. So in collaboration with the Department of Energy's Lighting Laboratory, we launched a research study to look at lighting exposures for the staff, and to understand if the tunable lighting system was really making a difference. So we compared it with their lighting exposures and their previous facility, which was under a static fluorescent system. We also wanted to know how occupants were just using the controls, because they did have the ability to dim or lower the light or raise the light levels. They couldn't change color temperature based on the cycle I shared with you, but they could override the intensity. And we also wanted to look at some clinical outcomes of the patients, which a medical group is looking at right now. But what I'm showing here is the lighting exposure data. And again, we made use of consumer grade wearables that were worn by the staff on their collars. And this was very different than just kind of taking a light meter and measuring the fixture or the light levels in the space, because it tracked the light they were getting from the system, as well as from daylight, as well as even from their computer screens. So it was it was a more accurate level of kind of the actual exposures the occupants were getting. And we did find a reduction in blue light at night. So kind of if you look at between 7 p.m. and 7 a.m., between the old and new unit, we were able to reduce the blue light exposures using the tunable light system. And for behavioral health patients, especially those who might experience disturbed sleeping patterns because of their behavioral health condition, that reduction in blue light is going to theoretically support their sleep and give them better sleep. There's a lot of research that's still underway about what's most appropriate for the third shift staff. And if reducing the blue light or intensity is a benefit to their health and to their alertness. But this type of data collection and monitoring is really a first step to moving toward this system that can be updated in response to new research that comes out, or changes in behavioral health programming, and ultimately to create kind of more adaptive and responsive environments where the lighting might even automatically change based on someone's individualized sleep and wake patterns. That type of thing I'm describing, which is often called like neuromorphic architecture, where a building is responding to and adapting to its occupants, sounds like a pretty sci-fi futuristic concept. But I think tunable lighting is an example that it's actually here and now, and the system can adapt and change based on occupant health needs, without having to replace all the lights and the fixtures. It can be done at the controls level. So now I'm going to turn it over to Romano to talk a little bit about schematic design.
Thanks, Meredith. The thing that you might wonder at this point is, well, how do we start to translate this information into an actual design? And we've found that that what we really need to do is to try to plug into the day-to-day behavior of and the operational goals of our clients, and to really understand, you know, their business model and how we can better align with what they're trying to offer to their customers or to their patients. So we've developed a process that is actually one that we've learned from manufacturing originally, called 3P, which stands for people, planning, process. Or actually, people have changed what the acronym stands for a number of times. But Meredith, oh, there you go. So within that process, there are a number of things that we do that use some of the tools that have been developed within industrial engineering and within Lean. And this first example here is a process map, so that we engage in a process mapping or a value stream mapping activity that helps us to first understand what the current state is for operations, and to then map that out. And in this case, the map moves from left to right. The different colored squares are different swim lanes within the activity, and for different stakeholders. And then each of the columns is a discrete step. And so the idea here is that by moving through a process and mapping it out, we then can understand what's required for each particular step. This is a two-step process then. The first is to understand the current state, and then to use the mapping. You can see the starburst yellow colors there. Those are opportunities where the current state could be improved. And that might come from just a way of being more effective at a particular step, or may tie into a new strategic goal or a new process that people would like to implement to improve the way that they're offering service to their patients. That allows us to then construct a parallel map that envisions an ideal future state. And so that then can be the basis for a design activity. And with that, we then have within the column of each of these discrete steps, the elements that would support a successful delivery of that step. And that might be environmental factors, that might be a piece of equipment, that might be a criteria for the way a space is put together. Something as simple as saying that, hey, we need a task chair there and easy reach to a printer. For that to be the most effective. And so what this does is it allows us to very deliberately understand the ideal process that someone would like to do within a space, and then to be able to take that and provide them with the tools and the support, the physical support in that environmental support in that space, to allow them to deliver that step successfully. So then the next piece with this is the 3P process is basically a workshop, and these can vary from a half a day to a series of week-long events. What I'm showing you here is a full week-long event, which is kind of our baseline that we use. And the way that this is organized is that we spend day one and part of day two really trying to understand and lock in what the objectives are, and that can be operational targets, that can be criteria for space. That was where we would have an understanding of the program, et cetera. And we're working in this case with a large group. A small 3P would still involve 20 to 25 different stakeholders who are involved. And in a healthcare setting, that could include care providers, that could include administrators, medical assistants, patient service representatives, janitorial staff, really anybody who has a stake in the new facility that's being developed. And the notion is that even in an organization that is healthy and thriving, we want to help them try to break down silos that they might have within their operations. And so we do this as a collaborative event. And then Once we have an understanding of how we're going to measure ourselves and have defined what success looks like, then we start to simulate space. And so we build full-scale rapid prototypes, basically mock-ups in cardboard that are full scale. And then we take we invite in other stakeholders, including patients, and then we simulate within those spaces. And so if we have an exam room, we have the provider and the MA bring a patient in, and we go through a simulated business. And when we look at the space around us, we then can see, hey, that this particular element may need to move, or we need more of this or more of that, et cetera. And since everything is built out of cardboard, it's something that we can easily change and move around. We have tried in the past using more fixed elements, like if there's a cart or a particular a sharps container or something like that. But to use that as part of the simulation. But what we found is that kind of tends to lock people's thinking in. They think that a decision's already been made, or we can't change that. And what we want to encourage by building everything in cardboard is for folks to still think that, hey, if I think of something that's an improvement idea, or that a better way to do this, that I'm able to make that change, that it's not locked in, it's not static. So Meredith, if you'll go to the next slide, please. A couple pictures here. That's why you see, entire MA stations, entire check-in desks built out of cardboard. The notion is that if it's something that matters to the process, we build it out of cardboard, and the only thing that's solid is something that you actually have to sit on, so that you don't have to build a chair that will stand up to someone's behind. With this, you can see that it's a very interactive process. Those of you that are designers know that when you're presenting a new idea, there's something about being able to see it as a sketch as opposed to a hardline drawing that came from CAD or Revit. And so we think of this as sketching in cardboard. And the beauty of this is that it's iterative. And so we are able to then, and in effect, honestly, it's really more about them, the stakeholders dialing in their process. And then a side effect is that we get an understanding of the spatial quality that's needed for them to be able to operate fully. So we are there not as the leader, but more so as the facilitator. And we often find that organizations have most of, if not even all of the knowledge that they need locked up inside their own organization. And our role is really to just help them unlock it, as opposed to us coming to the table and saying, do this, do that, do this, do that, which, I'm guilty of having done that at times in my own design career. Whereas this is very much led by the folks who are going to live in the space. And then for me, I mean, I'm the guy that gets to be there and say, well, it'd be really cool to have an 18-inch wide door at the back of the exam room that the provider could sneak in and out of, but we can't get that to pass code. That type of coaching is we find ourselves doing. So it's a wonderful process, and we have other opportunities during the week where we have an open house to bring folks in. We typically have the event catered so that people are spending 8-hour days together and having lunch together. And then we often have a big report out at noon on Friday with a big kind of celebration lunch. So it really becomes an event, and a lot of people liken it to going to camp, which brings back both fond and traumatic memories for many, but certainly something that people enjoy.
All right, so throughout the design process, we want to keep testing these models and these prototypes, because if we wait until a project is built, it's too late. So the simulations that Romano described in 3P are one way of testing. And then we want to do other things as well to to validate that the designs and the models are supporting the target transformation. So this is an example with a project. It was an inpatient it was an inpatient treatment center for persons with eating disorders. And kind of what you're seeing here is what they call the spa bath area. So it's where they shower, things to get ready in the morning. And there's also an exam room where they have weight and vitals taken. And there's several of these facilities at many different locations, but they expressed to us that they had a problem with kind of this bottleneck weight, and we realized it was because of the weight in to have vitals taken and for the exam. So we took there was a 3P event like Romano described, and then we took that prototype and put it into a software program called FlexM, and wanted to continue to test and make sure we were reducing these wait times and bottlenecks, as well as some staff movement. So the kind of spaghetti diagram you see there was a process map of their one of their existing facilities, and the red was the staff movement. So you can see there's a lot of back and forth crossing patient flows, and kind of just wasted movement. And when they're in certain locations, they also lose visibility over some of the space. So that's also something we wanted to test in the FlexM model. So we were able to put the 3P prototype into this program and run patients through. And we found that with a single wait station, the overall process throughput was still taking 3 hours. So we tested by adding a second one, and we were able to reduce it by an hour. So the total throughput was 2 hours. When we presented that solution to the client, though, the right people were in the right room to realize that they weren't aware that every patient was having weight and vitals taken every day. And this was something that, and having that knowledge, they said, oh, we don't need to do that full workup every single day. So this was a case where the root cause was actually incorrect policy implementation, and not really the design, a design problem at all. Romano, do you want to talk a little bit more about root cause?
That's something that comes from Toyota, which has been a great teacher for those of us in the lean community. This notion of root cause analysis, or as Toyota calls it, 5 whys. And it's interesting that had we not tried to improve this particular throughput in terms of taking care of these patients in the morning, we would never have helped them uncover the fact that they were not following their own operating procedures in the way that their clinician, their clinical director had indicated. And so the notion of root cause analysis and asking 5 whys, as Toyota would say, why are we having a delay? And then ultimately, why are we implementing this procedure that's not part of our standard operating procedure? Is an incredibly useful tool, and it's the kind of thing that, as you spend time around your clients and their operations, you begin to get a sense too for, oh, that doesn't seem quite right, and maybe start to ask those questions. So I've found that to be not only helpful to enrich my own understanding, but occasionally to help uncover an inconsistency or an opportunity for improvement as we move through a design process.
Yeah, so the process simulation not only uncovered kind of the root cause, but also helped us locate equipment and supplies, and then be able to look at patient and staff flows and make sure we were eliminating those kind of crossing points.
So one of the things that tends to come out of a 3P is that people will, when they first start, as Meredith noted, the first thing that they do is they kind of say, hey, let's just replicate what we've done in the past. And so we, on that first day, part of our job is to start to break down the thinking, so that people start to look at, hey, maybe there is a different way, a better way than the way that we currently do things. And that's just human nature. That's okay. But what we find in that process is that as people learn to see waste and their eyes open, they realized that, hey, not only do we have an opportunity with this new facility, but we have an opportunity to improve and fix where we currently are. And so that actually represents a tremendous opportunity within the design and construction process to improve and start the payback of the capital investment. And so what we find is that by taking improvements from the 3P and then applying them in the current space, in the current operations, we've seen return on investment shortened from the standard 7-year payback to 2.5 to 3 years, just based on operational improvements that start during design and construction. And so what we often find is that there are times where we need to design in a certain amount of flexibility, because with groups that do decide that they want to improve, that can even sometimes change what they learned at the 3P as they carry that spirit of innovation and improvement back into their current space. And so there have been times where we have designed in things like demountable partitions, et cetera, or using systems furniture in lieu of built-in casework, et cetera, that allow for some level of flexibility much later into the design phase. Because the reality is that there is a static aspect to developing a capital project. It does draw a line in the sand, but what we want to do is to the greatest extent possible to enable that to simply be a facilitating or an enabling factor in a much longer arc of continuous improvement for the organization, and to not be a hindrance. That I've had, unfortunately, projects that were designed, and then the duration of design and construction was such that we had to not only change, but or within the first year move in and after move in to do a remodel or a renovation to fix some sort of operational element that has evolved. And so we want to be thoughtful about how to avoid having that happen. And with that, it also ties into the notion that we want organizations to support organizations in their journey of continuing innovation and of evolution as thinking organizations. And so for us, we feel an obligation to really understand how we can support that through not only the design of the space, but also in a design and construction, in a capital project, to understand the last responsible moment for certain changes to be put in place without, obviously incurring extra cost or messing up the field schedule.
So we've tried to describe some ways of how we're integrating operational and human factors and space design efforts to achieve that systematic transformation. And so that a new facility project can really be a catalyst for system-wide transformation. But our story doesn't end here, because if we follow this current design process, this industry design process that we have, we arrive at a fixed endpoint, or kind of, Romano used the word line in the sand. So there's this completion state, and it's kind of fixed, and it comes at the end of this linear process. But in fact, the data-driven approach, where we're monitoring the integrated systems, really presents an opportunity for continuous evaluation and realignment, or essentially continuous improvement across a building's life cycle or meaningful increments of time. So we offer a provocation that our current design paradigm that uses this process, which has this fixed end product or endpoint, needs to shift to support continuous improvement over a building's life cycle. And this will also help us prepare for moving toward those adaptive and responsive architectures or environmental attributes that are going to be our future. So kind of moving toward that data-driven future. So we'd love to hear from you, kind of what's your reaction to this provocation, both conceptually and practically. How does our industry if we embrace that this is a future, how does our industry restructure relationships with clients, with construction partners? Who owns the data if there's this continuous monitoring? How do we get there? So we'd love to hear from you.
That's a really big question. I think we'll give everyone just a couple of minutes to respond. I'm just wondering, since you've had a little bit more time to consider this, what do you have any preliminary thoughts, or do you want to throw something up at the wall for a comment from the audience?
We've been exploring a lot of kind of the dashboarding environmental occupant data. So in the same way that dashboards are already being done for different sort of healthcare outcomes and tracking, to just kind of add this and both I think in what we showed you with the mood maps and the ring data, as well as kind of even the process maps that Romano shared with all the swim lanes. um, Once you have this kind of common element, whether it's timestamping or something, you can just begin to add more layers to whatever is a meaningful target. Um, so that's kind of one thing we're exploring, but for that continual monitoring.
On a much broader scale, we had a conversation a couple of weeks ago with Christian Towson, who's a professor at the Danish Technical Institute in Copenhagen. And his theory is that we need a lot of policy changes in the United States. He did a Fulbright here at UC Berkeley, so he had some understanding of the American system. And he said he felt like there's a lot more sort of legislation and rules which are put forth by the Danish government in terms of the broader idea of circular construction or a circular economy. Sorry. Anyway, I'm just wondering what role you think public policy and rules and legislation might make at creating a change within the design industry.
It seems to me that we as a paradigm in the country are more heavily capitalistic, and we have business interests that seem to govern. I mean, it's the existing paradigm, and I think we're blind to how it can influence. And so, it's interesting. There in the healthcare realm, we talk about not having nationalized healthcare. We talk about things that are allowed within that are all tied to what CMS will reimburse in terms of things that you can do, for instance, in an outpatient surgery setting, et cetera. So the market does respond to things like that. It's just that it feels more indirect, and it has more to do with what can be reimbursed as opposed to what can deliberately enrich or improve care. And so, we've spent a long time watching the emergence of outcome-based medicine and outcome-based practices, and that does influence, but it could certainly be more enhanced if the paradigm were to shift to one where there was public policy put forward that had kind of more specific directives and requirements as opposed to recommendations. And so we do find ourselves, there are clients who are more what we would consider progressive in terms of their adoption of notions of how to organize care and how to seek better outcomes. But that tends to be sort of left up to the individual provider, and oftentimes their motives aren't necessarily the same. Sometimes it might just be that we do all these cool and progressive things, say with the birthing unit, because that's what they feel like they need to do to compete in the environment. It feels sometimes like it's not necessarily tied to the best outcome for mom and baby kind of thing. So Meredith, this is more your area than mine, but of understanding this, but that's just my sense. And depending on your political persuasion, that might resonate more, as sort of a perception than depending on your views. But
Great. We have a comment here from Hal Maycomer. I'm sorry, Hal, if I pronounced your name wrong. I'm going to unmute you so you can make your comment to the group.
Great. Hi, Meredith and Romano. Great presentation.
Thanks, Hal. Good to see you, by the way.
Yeah, you too. Oh, you can see me? Great.
Or I see your name.
Okay. What you're proposing, particularly that the organization will be a learning organization, particularly in the organizations that are outcome driven. It's all about, every time that you practice, you get more data that you can learn from. Peter Senge introduced the idea of systems thinking being the fifth discipline of learning organizations. Yeah. And it's having a big impact on in terms of understanding the circular economy and how we might get to interrupting global warming. But I think that approach would be very useful. The idea of stocks, flows, reinforcing loops, feedback loops, delays, etc., all that could be a very useful paradigm for coupling what we do with architecture to what people do in their practice inside of that space.
I love it. Let's do it. I think that's a great suggestion. I realized early on, so even in design research, we still use the scientific method, which is a linear process that changes one variable, and the environment is a complex adaptive system. And so if to monitor it, the scientific method as a mechanism for studying and evaluating environments doesn't really work. And so I'm 100% on board with what you shared, Hal, that we need to kind of move to system thinking.
Yeah, the key point you're making there, Meredith, is it's not linear causality that we've got going on. It's concurrent circular causality that goes on in a organization, and that particularly is on changing on purpose.
One thing that I'd want to add to what Meredith had said too, when she was describing the use of the mood rings, I think one of the important distinctions there is that it's biometric data, that it's not subjective, and yet in that same experiment, the participants were actually pinged, and then they had to fill out they had to respond to describe what they were doing at a particular point. And I think that what that does, in these feedback loops that we can create is that it offers the opportunity for both subjective and objective data collection, and to have, for us as designers, I think there's a danger of, as we were talking about with the 3P of replicating what we figured out once in the past. I mean, it's very uncomfortable to enter a solution and then or enter a situation where you can't just rely on a solution that you've done in the past, where you're trying to do something new. Innovation is hard, and it often only comes when there's a stressor or a burning platform, I love that terminology, or burning the ships kind of thing. And so I think that in that, if you adopt the systems thinking that you want to have innovation as a part of it, you have to set it up in such a way, and you have to be able to measure both the subjective and the objective as a way to guide you along that path.
I'd like to ask each of you, Romano, and then Meredith, what's next? Like, what's the next phase of research that we need to start thinking about to make good decisions in the way that we design and construct buildings?
That's a good question. I was hoping Meredith would go first, so I'd have one think.
You can totally pass it off there, Romano. I'm totally down with that.
Well, for me, the drive is always to try to understand the value proposition, and to really to create a paradigm that will allow for value dialogue as opposed to cost dialogue, because we're measured by three things ultimately in design, and that's in the success of our projects, at least externally, and that's, was it on time, did it cost as much as it was supposed to, and did we get what we were supposed to get in terms of scope. And all of those are often reflected in cost, and unfortunately or fortunately, I guess, in our everyday language, cost and value are often used interchangeably, when in fact they don't have the same meaning at all. And so to have a value discussion and to create a paradigm where folks can understand, what problem are we trying to solve, and how can we be more effective? If that's how we're grounded, that's not really a research thing in my mind so much as a paradigm reset. But if I can get project teams to be in that headspace, I think we have a great shot of delivering a successful project. So how's that, Meredith? I gave you a few minutes to ponder.
Yeah, I fully agree with you. I think that we are not at this tipping point, evidence-based design or just kind of the data-driven design, because of value. I mean, we have the ability to do these things. We have the ability to collect data, to monitor human environment interactions, and even probably have the sort of architecture, at least systems, adapt and respond. But it's very much a value problem. Um, and so that's kind of what we're trying to address. And then I think on the research front, it's still sort of like trying to just identify kind of those target sort of layers of data and be able to understand the interactions between them to guide our decision making.
That was really terrific on the fly. I really appreciate it from both of you. I think we're sort of heading towards the conclusion of our time together. I can't believe how quickly this time passed. Meredith and Romano, this was just great. We're so grateful for your time and energy. Thank you so much. You've given us a lot to think about.
You're very welcome. Thank you.
So this will conclude CIDCI's online salon. This session will be recorded and placed on the CIDCI website this weekend. To join us for future webinars, be sure to subscribe to our newsletter on our website, cidci.org. Our next salon will be on June 4th with Canvas, a construction robotics company. We'll see you then. Special thanks to Monica Whistler for keeping us on track, and most especially to Meredith and Romano for a really wonderful presentation. Thanks for joining us. And as always, if you have any thoughts or comments, please reach out to us via the contact button on the CIDCI website. Thank you again.